Yes, excellent. Now, today I have defined you the Fourier series in the interval minus L and N, where L is any real number. Yes, okay. If f of x is periodic with period 2L and x, then x is equal to L by pi 2 pi. Okay. So the function f of x, which is defined as f of, in place of x, this is L by pi t. Okay. This is the Fourier series, just like you have to obtain earlier for the Fourier series for the function minus pi to pi, and similarly 0 to pi, and also you have to obtain the 0 to 2 pi. Okay. For this Fourier series, f of x, which is defined as f of, in place of x, L by pi t, n which is the same as 1 by 2 a naught plus n is 1 to infinity a n cos nt plus b n sin nt. Yes, okay. Where a0 you know, which is 1 by pi minus pi to pi f of x dx. So 1 by pi minus pi to pi f of, in place of x you write down L by pi t dt. Okay. Similarly, you can define as the Pn also. Yes, similarly you have to define the Pn also, or the Fourier coefficients you can also define that. Okay, now next one. Yes, that is An. Yes, similarly, which is similarly An, which is defined as 1 by pi minus pi to pi f of L by pi t. This is the function, and for an the coefficient is cos n t dt. Yes, okay. And similarly for bn you also you know 1 by pi minus pi to pi f of x. Yes, so f of L by pi t, yes, sin nt. Okay. Now for this interval minus L to L, yes, we substitute. Let us suppose that yes, that t is equal to, yes, this term, t is equal to n x by L. Yes, so dt is equal to n by L. Yes, sorry, not n, in place of pi t. Yes, so substituting pi t in place of pi, because substituting here is for pi. Yes, so pi by L dx. Yes, for minus pi to pi, if you suppose that the interval t is this one. Yes, x is equal to L pi by t, so you can obtain here, yes, t is pi x by L. Yes, from this here, so dx is equal to this thing, dt is equal to this thing. This is the same as here. Okay. So you can obtain now a0, yes, or a0, this can be done as, yes, and now substituting 1 by pi, yes, minus pi to pi f of, these are the limits from t, so substituting in t, yes, this to this, so you get for dx, and dx is equal to L by pi f. Yes, so this can be written as 1 by L, yes, minus pi minus L. Yes, this become minus L to L f of x dx. Yes, and because if you substituting here for the function, there is no change, because here is change only the in place of dt. Yes, if you converted this to in x, so dt is equal to pi by L dx So pi and pi is cancel out, or you can say that this one pi by L. Yes, and also here is 1 by pi. Pi by L is here, and also here is pi. This one, so this is cancel out, and minus L to L, the limit is minus pi, then this is L. Okay, so this term can be written as 1 by L. Yes, this pi cancel out, minus L to L f of x dx. And similarly, if you go for the an, yes, an is also substituting. Here is also pi by L, and here again is 1 by pi. Yes, minus pi to pi, the range become minus L to L. Yes, or f of function, this function is x, so is substituting. Here is x cos n t, and t become t is from this, where you get the t is this pi x by L. Yes, so this is cos n pi x by L. Yes, pi x by L. Yes, and it's here nt dx. Yes, okay, clear. And now similarly you can obtain bn. Bn is again, this is okay, this pi cancel out, so you get this one is equal to 1 by L minus L to L. Yes, f of x cos n pi x by L dx is similarly for bn. If you bn, for bn here is 1 by pi, and dt again this one, so pi cancel out, so you become also 1 by L minus L to L. Yes, f of x, the function is f of x, and sine of n t n pi x by L dx. Yes, this is the formula for the interval 0 and minus L and n. Similarly, you can obtain this formula as you had, yes, for minus pi to pi. This is a similar as the minus L to L. Here you change the function starting from here. This function you change here. Now you start this one a0 in this form. So you become, the function is this one. Now converting this, you get this one. a0 is this one. an is this one. bn is this one. Okay, you have cleared it? Yes. Again now the series is in half series. Yes. Okay, if you say that the series is in 0 to L, then the problem is the interval in 0 to L. In half series, if the function f of x, if f of x is defined, if f of x is in half series which is defined in 0, if f of x is defined in 0 and L. Okay, then we can find all the sine series and cosine series. Yes, so for the sine series, yes, f of x, yes, so yes, then we have for sine series, yes, sine series, yes, sine series, which is again in the form as you earlier have found out, sine series, which is the function for the odd functions. Yes, therefore you get the f of x, you get is equal to sigma n varying from 1 to infinity bn, yes, sine n pi x by L, where bn, you know where bn is, yes, where bn you proved earlier, bn is 2 by, because here is minus L to L, so this can be written as 2 by L 0 to L, yes, f of x sine n pi x by L dx. Yes, clear? Yes. Similarly, for the half series, if f of x is 0 and n, and for the cos series, yes. So also for yes, cos series, yes, yes, cos series you can write as f of x is n. You know that you get the cos series in which function? You get the cos series in form even functions. Then f of x, yes, you have proved earlier, which is equal to for cosine series, for sine series, yes, clear, for sine series, and also for the cos series you get half a0, yes, plus sigma n varying from 1 to infinity a n cos n pi x by L. And where you know a0 you know, or an you also know, yes, where a0, which is also you know that last time, yes, where a0, yes, where a0, yes, which is 1 by L minus L to L, yes, f of x dx. And similarly an, which is equal to 1 2 by L, yes, 0 to L, yes, f of x cos n pi x by L dx. Yes, this is the form you can prove this for the half series. That is the this is the result for the minus L to L, that is for minus pi to pi. Then you changes this function in this interval, then you can prove that a0 is this one, an is this one, an. Similarly for the half series, that is for the interval 0L, you get the sine series, this one, yes, for the odd functions, and for the even function you get the cosine series. These are the sine and cosine series. Yes, students, thank you. Next video I have defined you some questions of or some examples of Fourier series of the half series next time. Okay.